So next on stage, we have Kitty Pang. Kitty works for Alibaba, and I'm not sure how many people here know Alibaba, as their primary market is China. But by most metrics I can think of, Alibaba is currently the largest e-commerce company in the world. By transactional volume, I believe they're about a little larger than eBay and Amazon combined. So they're running a huge network, and looking forward to hear how you're doing that.
Thank you. Good morning. My name is Kitty Pang from Alibaba Infrastructure Service Department of Ali Group. Alibaba operates leading online and mobile marketplace, Intel and wholesale trade, as well as cloud computing and other services. Aliyun is the largest public cloud service provider in China. I guess most of you guys know about the Double 11 in China. It just like the Black Friday in US. During Alibaba's Double 11 shopping festival, the peak of the order creation volumes hits 8,000 orders per second, which was supported by Alibaba's cloud computing infrastructure. AIS is in charge of the infrastructure service for all of the business units of Alibaba Group. Here, I will share with you our practice and experience for cloud networking using OpenFlow and Westline. With our practice on SDN, what network problems have been solved and why we feel strongly confident about the virtualized network using SDN, and what kind of support we need from the industry experts. In the past few years, the demand for servers, bandwidth, and facility was growing explosively. And the basic challenge for us is how to make the infrastructure super scale, low cost, and high efficiency. As you know, the traditional cloud networking has the following limitations. The first one is a weakness in scalability. The second one is reliability. The bottleneck comes from the management of MAC address and app table. The last one is proprietary layer 2 virtualization techniques, which leads to the vendor locking. Here are some motivations behind the using of OpenFlow and Westline in data center network, and why migrate from the traditional techniques to overlay for network virtualizations. The first one is how to build the massive scale layer 2 domain to meet the requirement of virtual mobility within DC or between DCs. The traditional layer 2 techniques work well in the small network cluster, and cups of proprietary layer 2 solution already deployment for the cloud network for many years. But data center with tens of thousands servers, none of any traditional or proprietary layer 2 solution can work well. The well-known layer 2 bomb is big challenges: broadcast, unicast, and multicast. In our opinion, we should decouple of the virtual network topology from the physical network infrastructure and decouple of the virtual MAC or IP address used by VMs from the infrastructure IP address used by the physical network. So, which one should we rely on? Westline, NVGI, or Trail? Finally, we made a choice of Westline as overlay encapsulation technology. It was widely supported by industry currently. The scalability is the most important reason why we use the controller-based Westline solution. For the public cloud business, automation will be fundamental capability for operations, including provisioning and configuration. In the past few years, CLI script is being used widely, but we should use a new way for DevOps through SDN programming abstraction model, which can develop the network application easily. Finally, the hybrid cloud computing is what we need to go after. Here is the details of implementation, forwarding, and control plane mechanisms. From this diagram, you could see the overlay is on the left one, and the underlay is the right one. What are managed and controlled by SDN controller? Above the SDN controller, that is the cloud orchestration system. Here is Aliyun Cloud Management Systems. Let me explain the mechanism step by step. When a VM was created, the cloud management system will tell SDN controller the network information of this VM through the northbound API, IP address, MAC address, VLAN ID, and others. As the VM is activated, the first packet from the forwarding path is up, which is captured by rack switch and sent to SDN controller, validate this VM's IP and MAC. If match the information from the cloud management systems, the forwarding entry is created. Controller distributes forwarding entries to switch through the message of packet out. Packet out include up, MAC, and egress port information. And then subsequent traffic will be able to pass through the forwarding hardware, which is the legacy data path. Overlay network is used to provide the capability of multi-tenancy and layer 2 mobility domain. We tap encapsulate and decapsulate at rack switch and span switch. The same approach is performing the encapsulation at the Hyper-V switch. Okay. And let's deep dive into the detail of overlay network. First of all, what I want to emphasize is all switches used here are hybrid mode OpenFlow switches. OpenFlow is used as a communication protocol between controller and hybrid switch. First, with SDN controller, we can create different kinds of the layer 2 domains easily. Certainly, the multi-tenancy support is possible as well. The layer 3 gateway between the virtual network and the systems and the network service point on the physical network need to pass through high volumes of traffic. So we choose hardware as VXLAN layer 3 gateway. Currently, there is more high-performance merchant silicon switching chips support layer 3 VXLAN gateway functionality. This picture here is the typical network architecture for hybrid cloud computing. It can support coexistence of traditional switch and hybrid switch. It can also support coexistence of software-based VXLAN and hardware-based VXLAN. The V tab can locate in rack switch or Hyper-V switch. All the forwarding information is managed and controlled by SDN controller. I would like to make some highlights about our solutions. Firstly, all chipsets are merchant chip without any customization. Secondly, the control plane underlay is pure BGP IPv4 and the overlay is OpenFlow and netconf. For overlay networks, the Layer 2 VXLAN gateway at leaf switches and the Layer 3 VXLAN gateway at span switches. Due to overlay networks is irrelevant to physical networks topology, the endpoint should be a VXLAN capable device. That means rack switch, Hyper-V switch, and span switch is VXLAN capable. For physical network, we choose the multi-stage high-skill cloud architecture using eBGP at all of the switch. Automation for VM deployment and mobility management are conducted through a RESTful API between a cloud management system and SDN controllers. The SDN controllers interact with a switch through sourcebound interface, which are OpenFlow, netconf, and OVSDP also. Up is pushed into switch through the sourcebound interface, and normally the rack switch do not reply any ARP request. The multicast of underlay is not being enabled. After talking about the real case, I would like to share the whole picture about SDN in my mind. The blue component here means OpenFlow enable for physical server without function of overlay capable. The rack switch with VXLAN features can bring it into cloud. For x86 server, can use VXLAN capable of Hyper-V switch or virtualization function, NFV or service chain is supported here. In the WAN area, router can involve the SDN using PSAF protocol and BGP-RS. Transport network can do the same thing by PSAF. Obviously, other sourcebound interfaces are good at. Through the separation of forwarding plan and control plan, the unified scheduling, the whole picture will automatic provisioning and resilience will become easier. We achieve some benefits from our practice of SDN. The most remarkable benefit is the network can support the service with more flexibility. Purely BGP-enabled Layer 3 underlay network is very stable and simple. Another benefit is visibility of network operations. Well, in the traditional network, it is quite complexity to detect and isolate network failure. The typical method is to use ping or specific flow to trace the packet and measure the quality of network. But it is not efficient. VXLAN intention field provides the better way to detect the network problems, especially when performance or availability problems occurred, such as silence drop. The OpenFlow provides a more efficient in-action channel for operation with visualization. We submit an IETF draft on NOV3 group. Look here. To be honest, the SDN have not made remarkable device cost down. But in my opinion, the TCO goes down. The overall efficiency have been greatly improved without additional cost. And I believe it will make the cost reduction by standardization of a northbound API and a unified programming model. We gain some benefits, but there are still some challenges. One virtualization network have not perfect solutions yet. And the native OpenFlow switch is not ready yet because the OpenFlow enabled chip cannot satisfy the requirement of application in the huge scale scenario. Additionally, I would like to mention the standardization of southbound and northbound interface. It is quite difficult to standardize the northbound interface because the users is different and the service is different, and somehow hidden agenda for vendor locking. But it is very important. If a network is compliant with the right SDN standards, it would be controlled by multiple SDN controller applications. The SDN architecture will be deployed with large-scale network and interoperators multi-vendors. Last one, the performance of controller is another challenge we need to concern about. Finally, I would finish my talk here. I believe SDN will become new normal for network because it can help us to make the network better in terms of operation, resilience, and visualization. In the SDN framework, the ever-changing industry rules are taking place. Most of new features on the networks will be driven by end user directly. Consequently, this is a time the business network infrastructures and the ecosystem will be dominated by service operators instead of vendors. Thanks for your time.